Okay, so in this problem, you can see we have two reactions. There's a pin at A, so I've assumed directions for those. And then we had a two-force member with a supporting element, which just has one unknown, the reaction at B. Now, I need to take this distributed load and get a concentrated force, equivalent concentrated force, to help do my analysis. Now, if you decide to do the whole load as one piece, a trapezoid, it's not hard to find the area of a trapezoid. Off the top of my head, though, I cannot remember where the centroid of a trapezoid is. So I think an easier way to look at this problem would be to break it up into two pieces. One piece is rectangular and one piece is triangular. I still know very easily the area of a triangle, the area of a rectangle. I also know that the centroid of a rectangle is right in the middle, and the centroid of a triangle is 1/3 the distance from the taller, the bigger end. So those are things I think you probably remember and could use to your advantage. So with that said, let's find those concentrated forces. So the rectangular force, the equivalent rectangular force, I'll just call that F1, and then there'll be also one for the triangle. I'll call that F2. So what is F1? Oh, I left off the distances. Thanks. The distances are, this is 6 meters, and this little overhang is 3. Yeah. You need that information. Okay, so now, what are those values? Okay, it's 2 kilonewtons per meter times 9, right? So that should be 18. So I got 18 kilonewtons for that one. What about F2? That's a triangle, so it's 1/2 the base, which is 9 meters. And what's the height of this triangle? 2. So that's 2 kilonewtons per meter. And if we add all that up, it looks like it's 9. Okay? Now, applying my equilibrium to this problem, where's a good place to start? With my 3 equations of equilibrium. Let me pose a problem. Should we sum forces in the y direction first? Well, if we did, we would have AY plus the y component of B, 2 unknowns, and then balanced by these y forces. That's one equation, 2 unknown. Can't solve it. What about sum forces in X? Exactly the same. So your best bet is to sum moments about some point where a lot of your forces are concurrent. That's probably going to be this pin. So if I sum moments about A, I should be able to solve for B, and then I can sum forces X, sum forces Y. So that's going to be our strategy. So since I'm going to sum forces about A, I'm going to need the distance from A to these forces. I'll call that D2, and I'll call that D1. So what's D1? What's the distance from A to the centroid of the rectangular force? 4.5, half the distance. What about D2? Yeah, it should be 1/3 of that, should be 3. So it looks like I have all the pieces I need. So I'm going to start by, I'm going to sum moments about A, make sure it's in equilibrium, and I always use right-hand rule for my sign convention. Counterclockwise is positive. You can use whatever you like, but that's what I'm going to do up here. If you want to follow along, that's what I'm going to do. So starting with that, let's look at all my applied forces, both F1 and F2. Are they going to be positive or negative moments? With my counterclockwise is positive. They're all going to be negative. So I'll start with F1. So F1 is going to be negative 18 kilonewtons times its moment arm, which is D1, which is 4.5 meters. And then F2 is also a negative moment of 9 kilonewtons with a moment arm of 3. Now, how do I account for B? I think you want to break B up, right? You're going to have a vertical component I'll call it by, and a horizontal component. That's going to be a little harder to see in there. I should have made a little more room, bx. So what is by? What's by equal to? It's going to be b sine 30, right? So again, I'm back to just that one unknown. So what's the moment arm for that? Oh, first of all, is by going to create positive or negative moment? Positive. So I'm going to have plus b sine 30, that's the force, and the moment arm? 6. So somebody solve for b, and what do you get? You should get a positive number, so we assume the right direction for b. Let's see, 4.5, 3, 12, 13.5, 17.5, I'm guessing. You might want to have your calculators handy when we work problems. Yeah, the first problem, find your calculator. I don't know. I got 36. 36? Even? Anybody else get 36? You get it, Mr. Young? Okay. 36? Sounds good. So it's 36 kilonewtons. So I got a positive value, so I chose the right direction to be. Your next step could go either way. Some forces x, some forces y. I'll just sum forces in the y direction first. So I'll assume up is positive. So I'll sum forces in the y direction, make sure they're in equilibrium. So what do I have in the y direction? I've got AY acting up. I've got BY also acting up, which is B sine 30. And then I have my two forces, F1, F2 acting down. So that's 18 and 9. So what's AY equal to? 9? Anybody else get 9? Confirmation? Yes? And again, got a positive value, so I assume the right direction. And then finally, some forces in the x direction, I'll assume to the right is positive. So looking at my free body diagram, I have AX plus the x component, which I didn't write before, but that's going to be b cosine 30. And anything else in the x direction? No. So what's AX? Negative what? 31.2. 31.2? So there we go. So any questions about that one? Pretty straightforward, I think.
Is that one out of the book, or is that just in the notes?
Say that again?
Is that one out of the book, or just from...
No, I think I pulled that out of my notes.
Okay.
So I'll stop here.